Everyone, we will solve this today's LeetCode problem. The question is robot collision. So it's a LeetCode hard. Let's see what the question is asking. So there are one index and one index robots, each having a position on a line, health and movement direction. You are given zero index integer array, positions, health, and a string directions. So direction can be either left or right. Okay, and all integers in positions are unique, right? All robots are start moving on the simultaneously at the same speed in their given direction. If two robots ever share the same position while moving, they will collide. If two robots collide, the robot with the lower health is removed from the line and the health of the other robot decreases by 1. Right? The surviving robot continues in the same direction it was going. If both robots have the same lane health, they were both removed from the line. Your task is to determine the health of robots that survived the collision in the same order that robots were given. The final health of robot, okay. Return an empty array if there are no survivors. So basically, the question is asking to the health of return the health of the robots after after complete movement after complete movement, right? Between their movements, between their movements, between their movements, they can collide if they are comes they come in between their in between their paths, right? Between their movements, they can collide if they come if they comes between their paths, right? Their paths, right? And there are conditions of collisions. There are conditions of collisions. What are the conditions of collisions? So the first condition is that if they collide, so the lower health is removed from the line. It means if a health is less than b, right? If they collide, if a health is less than b, then b will be removed, and a health will be, okay, let's take as a pq, right? Or take as first and second, right? So the second will be removed, and first health of first will be decreased by 1, right? That's the decreased by 1. That's given here, right? That's the condition, right? And if second condition is if both health is, so this is a health, right? This is health, this condition is health. So this is a first and second representing health, right? Representing health, right? So if health is both health is same, then both will be destroyed or removed, right? If both of the health is same, right? So the question is given this, right? And the direction they are moving in, that is either left or right, right? Okay. So and finally we need to return the health of robots health of robots in the same position, at the same positions, which is given in question, right? At a starting point, right? So if you see here, we have given a positions for each robots. The first robot is at 5, second is at 4, third is 3, and that's how the positions of robots is given. Health is also given of each robot, and direction is also given as a string for each robot, that in which direction they are moving, right? So this is the basic questions we understood, right? Okay. We saw conditions of collisions, right? We will remember this. We also see that they are moving in left and right direction only, right? So basically, how we will form this? So first thing is for sure that the positions, for positions, because they are the robots are in different positions, right? The robots are in different positions. So if you see in this example 3526, we need to arrange the robots in the sorted order for sure, because the position is given different for each robot. The first robot is at 3, fifth robot is at 2, second robot is at fifth, third robot is at 2, and the last robot is at sixth position, right? So the robots positions are in random order. The robots positions is given in random order, is given in random order, but they are uh, so I need to just figure out the positions also. I need to return the answers according to that positions, right? According to that positions. So first thing is to clear that I need to rearrange these positions according to the sorted order, right? So for that I need to sort the positions. Need to sort the health of the positions, right? I need to rearrange the robots in sorted order of their positions, for sure, right? For sure, right? So for that, what we need to do, we will just sort all the robots with these positions, right? So we will store the positions of each robot with their with their health, right? With their health and directions also, right? So that's for sure, right? One thing is clear. The second thing, the second thing is the second thing. If you see, we need to just focus on health. We don't need anything, right? We just to focus on health. Suppose there is nothing given, right? This is not given, this is not given. Let's suppose the question is just like the question let's suppose the question is just like question like uh, the robots are given and their health is given, right? The robots are their position is not given, only health is given. In this case 10, 10, 15, and 21. But just if this is given, this is for first robot, this is second robot, this is third robot, and this is fourth robot, right? We will see this like this, that if this there is no position, their health is only given, right? Health of robots is only given, only given, is only given, and there is and the robot is and the robot is placed in order, in the same order which is in the same order which is given, right? Without sorting, right? Without sorting, without need to change its position. So first robot is here, second robot is here, third robot is here, and fourth robot is here, and its direction is given RL, right? In direction string, right? So this question is just like a problem, a famous problem, asteroid collision. This question is just a famous problem, asteroid collision. If you observe here, in asteroid collision problem, if you have not solved, I urge you to solve that question. But I will also tell you what that question. Let's show me the question to you. Asteroid collision. Yeah, this is the question. So basically, the question is the asteroid collision is the same collision. It's a medium one, right? It's a medium one. In this, we don't have the question is just changing to that here. When the two collisions occurs, the lower one get destroyed, the lower value, and the direction is representing by positive and negative sign of the numbers given, right? That's the question is here, right? It's the same problem, just a slightest modification. Direction is given as a minus and positive is for right direction. That's the same problem. And when both of the collides, the lower one gets destroyed and the largest one remains same without any health issue, without any health, right? It's the same problem, and we will solve that like that. So in this question, the direction is representing as a plus and minus. So what I will do, I will do the same thing. What I will do, I will make the I will change the health of, will change the health of robots which is moving, in left direction. What I will do, I will make them negative. I will make them negative. I will do the same thing for them. What I will do, I will change the directions. I will change the health of that numbers. So what I will do, I will change 10, then minus 10 because it is moving from left. Then right, it is 15, and when it is moving in the left, I am doing minus 21. Right, the same thing. So what I have done, this negative value. So one thing is clear that I don't need to check for directions now, right? I am free for directions, right? I need to focus on this health and this position right now, right? So I'm just focus on this. So minus is value is representing left direction, and so negative value represents left direction, right? Negative health value, that for sure. Now I'm sure about that, right? Now how we will how we will how will how will we found we find the final health of all the robots, okay? So if you see here in this, when we when this two collides, when this two will collide, 10 and minus 10, what will happen? This 10 and minus 10 will destroy each other, right? This two will be removed, right? Left with 15 and minus 21. When this 15 and minus 21 collide, because this is moving in left direction and this is moving in right direction, so this will definitely collide, okay? And one thing also clear, that suppose the height is given minus 10 and this is given 5 and 5, so this both is moving in left and this is moving in right with the same speed, right? Because in the question we have given they are moving in the same speed, so these two and these two will never, they will never collide, right? So collision will only occur when they are moving in opposite directions of each other. When two robots are moving in opposite direction, right? In their opposite directions, in opposite direction, right? So then only collision will occur. So these two and these two will never collide, right? That for sure. But these two will definitely collide. So when they collide, this 15 is less than this 21. Don't see this negative. This is just for direction. This 21 is greater than this 15. So this 15 will be destroyed whole, right? And this 21 will be reduced by one health, which is given in this question, right? Degrees by one. So this 21 will reduce by 20 and this 15 will definitely destroyed by whole. So now this 10 and 10 all destroyed, this 15 is destroyed, so only 20 is left. This robot is left with the health 20, so ultimately the answer is 20, right? Right, that ultimately the answer is 20 here, right? That's the question was given, right? So ultimately the answer is given 20, right? So the first thing is we need to collide, we need to see that which two elements, which two robots are collide, we need to see that, right? We need to definitely know that which two robots are colliding, which two robots are colliding. So basically what we need to do, we need to find pairs of robots for sure, pairs of robots. And whenever something pair some whenever we need to make we need to find pairs of something, we think of the approach, we think of the approach like a stack, right? We think of it up to approach like a stack or just vector, right? You can use whatever you want, both acts like the same, right? We can use both, anything else. So when you what you do in valid parenthesis type of problem, in valid parenthesis type of problem, we will do the same thing here, right? In valid parenthesis you find pair of open and close. Here we are finding the pair of right and left, right? That's what we are finding here, right? So we will use the same concept which we use in valid parenthesis, right? So for each and every left value, if for each and every left value, if I got a left value, if there is a right value before this left value, it means they will definitely collide. What I'm telling, that there if I encounter with encounter with the robot which is moving in left direction, and before it, if there is if there is any robot which is moving in right direction, they will definitely collide, they will definitely collide, right? This is what I'm claiming, and this is for sure, right? This is not just claim, this is sure. So definitely they will definitely collide, right? So it means I need to figure out the robots which is moving in right directions, for sure, moving in right direction, right? So what I will do, so suppose here it is given an example, an example. Let's just take, I'm not talking about positions, right? This position part is still left. I'm just talking about when robots are in still in order. Robots are in still in order. I don't know that I'm just knowing that robots are in still order. The positions I'm not talking about yet. I'm just talking that position is still order. We will talk about this position later, because this is just nothing, this is just a arranging, right? So this position is in order. So when I try to see these things, like when I started when I started moving, so the direction is given, let's suppose this is given RL, right? So what we will do, we will change the sign of this. So this is negative, so we will minus 17. This is positive, this is negative, minus 15, and this is positive, right? So now the first thing that we will use a stack for right directions, right? And when we encounter left, we will check in the stack position that whether we have or not. So we have a right directions, so we will put this in our stack, right? So two is in our stack. Let's put this to or stack, or take a vector, when whatever you want, right? Right direction robots, right? Right direction health, right? So 2 is here, right? When encountered with left value, which is moving left, it means it will definitely collide if I have a right direction. So I have a 2, right? This 17 is greater than this 2, right? This 17 is greater than 2. It means this 2 will definitely will remove. This 2 will remove. But this 17, this 17 will decreased by one value. And when we decrease by one value, it means it will decrease to 16. Don't see this negative, right? This is just for direction. When we want to decrease this by one, this will reduce to 16, right? So uh, the final, what will the final 2 minus 16, sorry, not 2, 2 is destroyed, 16, 9 minus 15 and 10, right? This is now, now this 16 is a minus, this is moving left, right? If this is moving in left, so one thing is for sure, if I don't have any extra right direction, it means this will not collide with anyone, right? If this is not colliding with anyone, it means this robot will remain in my answer, right? This will never collide and this will remain in my answer. So this robot will be in my answer, so I will just store this health, right? Which is absolutely 16, because I have put this negative. The question was not in negative, right? So I will put 16 here, right? Now when I move to 9, this 9 is positive, this is moving in right direction, so I will insert this in my right direction. Now when I got minus 15, this is moving in left direction, right? So this minus 15 will see that whether we have a right direction health or not. Yes, we have, right? We have. So this ninth direction will just get collided and removed, right? This nine direction will get collided and removed. So this will be removed, and this 15 will also reduce by one. So this 9 is removed. So this will now change to minus 16, and 9 is removed, and this is reduced by minus 1. So this will be minus 14, and now again this is 10, right? Till this we have covered. Now this is again 10. So we will insert this here, right? And also this 14 will be in my answer, because this is again a left direction, this that will never collide with anyone. So this is 14 again, with this is 10. So direction health is 10, we will store that. After this, the robots are ended. So one thing is clear, that this will move in right, this all will move in left, they will never collide. So the stack which the values which are in right direction health remaining after iterating in all, that would also include my answer, right? So this is my final health, right? This will be my final health. So in this is very simple example. Let's just twist it, right? Let's just twist it to some other examples. Let's make this as a, okay, let's just make it as a 15, and this makes as 9, right? Let's do this. And also let's just make this minus 9 minus 10, right. I'm just changing directions, right. Now what will happen, let's see. So when you and also what we think, yeah, when you see the first two is here, so right direction health same. So this 2 will here minus, now this 16 will remove, destroy this and decrease by health by 1, right. This okay, I have changed the question, right. It was before 17, I think. Yeah, it was 70, right. So it was 70, right. So if you see this 2 will be here, and when we move to 17, this 17 will destroy this definitely. So this will be destroyed. Now 2 is destroyed and 17 is at left direction, so this will be the final by decreasing by 1. So this will be the 16, this will be 15, this will be minus 9, and this will be minus 10, right. And also this 16 will be stored in my answer, right. Now when I move to 15, this is right direction, right. This is in right direction, so 15 minus 9, this is in left direction. So this will check whether we have right direction health. Yes, we have. It means this will definitely collide with it. So when this will collide, this minus 9, will be left out. This will be removed. If this will be removed, we just need to change this 15 to 14, because health will be reduced. Remember, this health will be reduced. So this 14, this 15 collide with 9, and this get removed. So this will be removed, and this change to 14, right. Now again 14 is still in my direction health. Now we have moved to minus 10. This 10 is in left direction, so this will definitely collide with right direction. So this 10 and 14 will again collide. So 10 is less than, so it will again removed, and this 14 will change to 13. This 10 will be removed, and this 14 will change to 13, right. Now if you see here, in this 16 is already stored in my answer, and we have left with 13 in my right direction health, right. So this right direction health with 13 is left only. So this will be definitely will be in my answer, because this both are in going in left and directions, right. So this will never collide. So this will be the robots health which are left. So basically what we are doing, we are just checking for so the same thing, right. Whenever we are encountering the robots which is moving left directions, we are checking whether we have right direction left or not, and act accordingly the conditions of collision which is given here, right. And this is just a implementation. How will you do that, right. It's just an implementation purpose. One thing we have not discussed yet about the positions, right. Till this asteroid collision problem would be solved, definitely, right. This question will be solved till this, because there is nothing like uh, problems uh, of positions there, right. Asteroid collision will be solved till this. Now for this problem, this whole concept will be applicable here, but the slightest modification is this positions. This position is selected for random robots. See, the first robot is at third position, which is here. The second robot is at fifth position. So this is not given in order. Right. And we know that I need to, when I want to see collision, this needs to be in order, right. So what I will do, I will just make up, arrange these robots in positions order, right. So for that I will just sort this health according to these positions, right. I will just sort this health according to these positions. So what I will do, I will see that's 3, 5, 2, and 6, and this is given 10. Let's make a space, this and this. So this is 10, this is again 10, and this is 15, and this is 12, right. So the first is 2, 3, 5, and 6. So at 2 position, which is 15, let's make space here. This is 15, this is again 10, this is 10, and this is 12, right. So this is now the order of the health of the robots, and act on this we will act on this. we will apply we will apply the above approach on this health, right. On this health, right. Not on this. We apply the above approach on this health, and the answer which comes, and the final and the final sorry health which will come will be will must be arranged according to the above position, must be arranged according to the above positions, right, at the starting position which is given, right, which is given, right. We will store this all the health according to the given positions, right. So if there is no health left with any robots or destroyed, so we will not store not see not return in what vector, we will just remove that, right. So we will just maintain this order if the robot has a health, right. So now we will just see implementation. You will be you will better understand. But I suggest you to implement by yourself. First, first implement your. I suggest to first implement by yourself, because this question is not just hard. This is greater than medium, high medium problem, not but less than hard, right? But less than hard, because it is not hard to think like we will use a stack and we will see that, right. This is just a high medium, but you just need to implement this very carefully, right. So the first thing is that we need to see arrange the positions of health according to the according to in sorted order, right. So we will just see the positions dot size, right. Now what I will do, I will take a pair to rearrange the health, right. So I will take order health. Let's take a order health, right. Order health. Also, I need a vector to store this right direction health, right. Right direction health. So I will also take a right direction health, right. Instead of right direction health, you can take a stack also, right. It is totally upon you. it, this is it's totally upon our implementation, that what you implement, right. This is just analogy of I'm just taking instead of a stack, the vector, right. I'm taking vector as a instead of stack, right, simply. So what I will do, I will just store all the I will just store in ordered health. What I will store, I will store positions, the current positions and the health in pair, right. So for pair, this needs to be in this needs to be in curly braces, right. This is position, this is first, and this is second. This is will be just a store. But before this, remember that I need to also change the directions, right, by changing negative. So right direction is positive and left direction is negative. So before this, what I will do, I will just see that whether directions of I is left or not. If it is left, what I will do, I will just change this health change this health. Okay, this is health, right. Change this health to minus, right. I will just change this health to minus. That's change I need to do just, and I will insert in position, right. After that, what I will do, I will just sort it according to the positions, according to the position value, which is order health dot begin dot order health dot end, which is which will be short according to this position, because this will short according to the value which is in the first value. If you want to do with second, you need to make a comparable function. That's why I have just insert this at first position, right. So just short it on the basis of the first positions. Now what I will do, I will just iterate again in this whole order health. Now I don't need this health, I don't need this positions, I don't need this direction. I will just focus on this order health and this right direction health, right. So what I will do, if the order health if the order health is if the order health of I is less than if order health of I dot second, which is representing health, the second is representing health, right. Okay, let's just uh, try that. This represent first is representing position and the second is representing health, right. Remember that its implementation is a little bit messy, but yeah, this is how the hard problems occurs, right. So the order health dot second, if it is greater than 0, If it is greater than 0, it means I need to just store in this my right direction health. So I will just, what will do, I will just store in this right direction health the order health I second, right? Because I need to store in my vector to C, right? Now when I get a left direction robot, I will check for right direction health, that whether we have a right direction health, right direction robot or not, right? So for that, what I will do, I will check that whether I have. So if this health, if the current health is less than 0, it means the robot is moving in left direction, and I will check whether we have. So this is just for checking that it is empty or not, right? And if we have, what I will do, I will just check that whether this order health, again the same thing, that whether this order health, whether this order health, last order health value is less than of absolute value of current health direction, right? Okay, let's analyze this what I've written. This is just a checking for whether we have right direction robots or not. The order health I dot second is, if it is negative, it means I will just check whether the last direction health is less than of order health is not. If it is less than, what I will do, I will just remove this, because this will get destroyed for the of this order health directions, right? So we will just remove it, right? So what I will do, I will just remove it. So v1 dot pop back. Also remember that this order health dot second health should be also decreased by one value. So what I will do, I will just increase it by, it should be decreased by one value. So this is negative right now, right? This is we have done with negative. So for reducing it, I will just increase by one, because it's a negative. So I have, so I have just increased by one, increased by one to reduce this, right? So I have reduced this health value, right? Also after this, so what will happen whenever you get any order health again and again, and if it is greater than this, the last right direction values, sorry, this is not v1, this should be the right direction health, right? Why I have changed the variables, this will be the right direction health, right? So this needs to be just pop back, right? And now what will happen after this? So there are some cases left, that if what if the at last, what if the it is same, right? We have not taken for the same values, but what if it is the same values? So if it is same values, so I need to check for further cases, right? If it is the same value, I need to check for further cases. This is just for when it is less than value. So I need to just check for again, that if the right direction health dot empty is not empty, and this is equal, this is equal, this is equal values, right? This is equal values. If this is equal values, and also what need to check, that vi dot second should be less than, right? Vi dot second should be less than. So this is less than, and this is equal, right? uh, I have chosen the value, very long name, so it's very complex, right? So if it is less than, and if this direction values is equals to this, it means both needs to be destroyed, both needs to be destroyed, right? So this both needs to be destroyed, so right values should be popped out, right? Also we don't need to uh, we don't need to see this order health values right now, right? This need both needs to be popped out. Otherwise just we need to decrease the health of this right direction value, right? Just need to decrease the right direction value if it is greater than, because we have checked for less than, we have checked for equal, and if it is greater than, we will just decrease by value by one, because this value would be positive, so I will decrease by one, right? At last there is possibilities that this ordered health value is remaining still, and we don't have any right directional value. So if this robot is left with in moving in left directions, so I need to check for further also, that if we have a left values still remember still, right? So if this right direction health is got empty, right, it is empty, and we have still left with the left moving robots. So I need to insert in my answers, because the robot which is left and moving in left direction will never collide again, right? So I need to store that in my answer, right? I will need to store that in my answer, and this is less than 0. So I need to store that in my answer. So what I will do, I will just store in my answer, which is uh, so what I will do, I will just store in my answer. So let's take a vector which is take answer, and this will be stored in my answer, right? This will be stored in my answer, right? But do you think this is correct? No, this is not correct, because we have a positions. See, remember, we have a positions. So I need to store with the position itself. I need to store with this position itself. So for storing within the positions, what I will do, okay, and one thing also, there is some implementation error, which is this this right here, right? I need to store this with the positions, because we need to focus on these positions also, right? So we need to store this within the positions, right? So let's just store the positions, which is, yeah, this is the second part, and the first part is its position. So let's just store the position which is at first, right? So what is happening here, this first is representing health, and the second is position, right? That's what is happening. First is health, and the second is position. Now if you see here, we need to store according to the position. So for that, what I will do, I will take another data structure, a mapping, for storing according to the positions, right? So what we'll do, this MP, so instead of just storing an answer, I will store first the positions, which is order health dot dot first, and I will just store with the answers, which is the second, right? This, what is this will happen, what will this do, this is my final answer according to the positions, right? This is the final health of robot, of a particular robot, right? Of ith robot of a robot, right? This is the final health which I have stored according to the positions, right? Now, so one thing you have seen here, that if both is destroyed, so not need to be in my answer, right? So this, after this should be continue, right? This should be continue, because if I don't continue, this will go and get stored in my answer, right? So which should not be stored, because they are already destroyed, both are destroyed in this case, right? So this is how we have stored all the final values of health according to the positions of each robot. Now after this, I need to return the vector of each robot according to the position of starting, which I have done. So what I will do, I will take as an answer. Now I will, okay, one thing is also left here, that in this right direction health, there are right direction robots can be left out, right? So I need to store them also, right? So for that, I will start iterating in this right direction health array till its size, and store all the final values of robots in my map according to the this according to the right direction health, because in the right direction health I have also stored the positions, right? So the first is health, and the second is time, second is position. So second is position, and the first is health, right? Right. So this is better. Now what I need to do, I need to just iterate in this position array and store according to the position array. So I will just move in position array, okay, and store in this vector. So this vector needs to be in upper part, and answer dot pushback mp of this positions height, right? This will store all the health in the order, and we will just return our answer, right? This will do. But one thing, if you have not remember that I have changed the values of health, right, to represent direction. But in the question, if you see, we don't have negatives, right? We need to change it. So what I will do, I will just take an absolute value of health to make them as a positive, right? So this is how the answer should return. Let's try to run this. There must be a compilation error, I'm sure about that, but let's see. Okay, there's the wrong answer. Let's analyze what the wrong answer here. It's very very wrong, right? Let's see what happening. So first thing is for sure that we have maintained order health, and we have pushed it whenever I got a direction L. So positions I and health I have stored, I have sorted in according to the positions. Till here I think it's correct. Now what I'm checking that direction health should not be empty, and ordered health I dot second, which is a health, is less than 0, and right action health dot back dot first, which is uh, okay, I'm storing correctly, right? Right, to push back ordered health dot second, which is health, and this is just a position, right? Right. So this should be right action dot health is dot first is if it is less than the order health dot second. So if it is less than, then right direction health dot pop back, we will pop back this right direction health, and this order health I dot second should be decreased by 1. So this will be decreased by 1, right? And now what we need to do, we need to just check after this that if it is not empty and this order health dot second is less than 0. So we will check for first value, that this first value is equals to order health after second, and we will pop back and continue on this. Otherwise we will just change this direction health to dot first value. Till here it is also correct. What is wrong here now? Order health I dot second, if it is greater than 0, uh, if it is greater than 0, I will push it in our answer, which is the second one, which is representing health, and the last one is representing the position. Okay, and the direction health is empty, and order health is dot second is less than 0. So we will store the first is the position, and the second. I think this is correct. What is happening? Mm, the size dot first is correct. Okay, okay, okay. In order health, the first is position and the second is health, right? Okay, this is the same. The first is position. Okay, this is right direction. No? This should be right direction. This is not order direction. This is right direction. In that direction, the first is health and the second is position. So this will be the right direction, not the order direction. That's the wrong. Now I think this just to be changed. Okay, again something is wrong. Oh, okay. Before inserting in answer, I need to check that whether I have answers or not, right? Whether I have answers or not. So before inserting it, I will just check whether I have positions left in not. So if mp.count this positions in my answer is available, then I will insert this health, right? Otherwise I will not insert in my answer, because if it is 0, it should not be there, right? It's not be there. So I will just check whether we have positions left or not, and now this will be definitely fine. Okay, yeah, we have just submitted. Yeah, we have passed all the test cases. Okay, so there is lots of implementation. So we will analyze the from the starting part. The first thing is that we have arranged according to the positions. So we have sorted it according to the positions order. Now we are checking for that whether we have right direction left if we are encountering with any left direction robots, right? So if it is there is a robot, then we have just popped out if it is value is less than that, other and also decrease its value by 1. After that, if both robots have the same health, so both will be destroyed. So we will destroy it by both, and we will don't store this. Otherwise, if it right direction health is greater than the left direction health, left direction will be destroyed and we will decrease by 1, right? And we have stored all the directions according to the position, so that we can store the finally positions according to the right directions. So we have just stored all the positions in the right directions, and just how we will return the answer, right? So this is just an implementation. We can also reduce implementation somewhat. So instead of uh, using this again, we can change this like, uh, don't check this here in the starting while loop. Just make this as a if conditions in here, right? And this will work fine, I think. Just make this like this, and this will be changed to pop back, and this is negative, and this will be changed to this, right? Now, instead of checking like before this, we will just check this for here, right? So if if the direction if the same conditions happen, so we will just broke out, because this order health is second 0, and we don't know what happens at the last, right? So we will just change this to 0, right? So let's analyze again. So if it is 0, we don't need to check that, right? We don't need to check that, we just need to check this. Yeah, I think this will be now applicable to all. Now instead of this continue, we need to break this, because this is both will be destroyed, right? This health is destroyed and this will also destroyed, so this needs to be break. Also, for this condition, we also need to break out, right? This also needs to break out, so this will be breakout for this also, right? Now this will be broke out, and also right health will be decreased, the same thing. Now what will happen, I need to figure out that this is breakout, right? So that I don't move further. So what I will do, I will just analyze with a bool flag value, which is 0. And if it is a 1, so I will not move further, right? If it is a broke out with 1, so I will not move further. So what I will check after this while loop, whether it is flag 1, so I will continue on this, right? And I think all the answers would be same. This is the changing we need to just done. Why I have changed it? Because this, if it is equal, we don't need to push it back, right? If it is greater than, we also don't need to push it back, because we haven't removed that, right? That's why we have continued it. I think this will also work. Let's just run this. Yeah, now just submit it. Yeah, we have successful. So see, we have just done in one go, right? And that is the correct implementation. This is optimal implementation we have. So yeah, let's analyze the time and the space complexity. So time complexity is, if you see here, the first O of n for storing, the then sorting on the basis of that. So O of n log n for sure, right? O of n log n for sure, and is number of robots. So O of n log n for sure. Also, we are iterating in only one times in O of n. This while is also iterating only one, so overall is O of n only. So the final time complexity will be O of n log n, and the space complexity would be the first vector order health is to stored on the basis of position, so O of n. The right direction health is also O of n in the worst case. So basically, it is O of n plus O of n. Ultimately, is O of n. So this is the space and the time complexity for this problem, right? So yeah, you can solve you can solve asteroid collision also with this approach, right? It is an easy one. You don't need to worry about position, direction. It is just given in the question itself, right? You can solve uh, the asteroid collision and all, right? So yeah, thank you so much. Bye bye.